Good evening, everyone. My name is Andrew Fracknoy. I'm the Emeritus Chair of Astronomy here at Foothill College, and it's a pleasure for me to welcome everyone here in the Smithwick Auditorium in Los Altos Hills, California, and everyone watching us on the web around the world to this program in the 18th Annual Silicon Valley Astronomy Lectures. This series of outreach lectures, which by the way now has over 2 million views on YouTube, is co-sponsored by 4 organizations: the Foothill College Astronomy Program, NASA's Ames Research Center, the Astronomical Society of the Pacific, and the SETI Institute. And today we actually had additional help in publicizing the program from the Planetary Society. We're very grateful for that. This series presents non-technical talks for the beginner on exciting new developments in astronomy, and nothing meets those qualifications more than tonight's topic and tonight's speakers. As many of you know, the New Horizons spacecraft passed by Pluto a couple of years ago and sent back remarkable information and pictures from Pluto, and is now on its way to see a much smaller object in the zone beyond Neptune, which we call the Kuiper Belt. And tonight's speakers are not only involved in that mission, but have written an exciting and well-reviewed new book about that mission called Chasing New Horizons. Our speakers are Dr. Alan Stern and Dr. David Grinspoon. Let me say just a few things about each of them. Their resume is so long I can't possibly do justice to all the things they've done and written. But let me just tell you that Dr. Stern trained both as an engineer and as an astrophysicist. He was the science leader of the New Horizons mission and has been involved with over 20 other space missions as well. For a time, he was the associate administrator at NASA for science missions, and he was twice named to Time magazine's list of the 100 most influential people. He has been the author and editor of 6 books for the public and has won numerous prizes for his work, including the Carl Sagan Memorial Award. Dr. David Grinspoon, who has spoken in this series before, is an astrobiologist and an award-winning author and public speaker. He held the inaugural chair of astrobiology at the Library of Congress, has worked for science museums and institutions of higher learning, and has been on the science team for several planetary missions. His books include The Earth in Human Hands and Venus Revealed. Ladies and gentlemen, talking to us about chasing new horizons inside the epic first mission to Pluto, it is a delight and a professional privilege for me to introduce Dr. Alan Stern and Dr. David Grinspoon.
Thank you very much, Andy. I'm David. I'm going to talk for a few minutes, and Alan will talk for a few minutes, and then we'll hear what you want to know and entertain questions and discussion. By the way, Andy, congratulations on topping 2 million hits for this series. Yes. What you do with this lecture series is so cool. The spreading of the knowledge of space science to the masses of people that are hungry for this inspiring science. We really appreciate the work you've done. So thanks for that. And I'm really excited to be here tonight with Alan to share a little bit about the story of New Horizons with all of you. This is a story that I've been fascinated with for a long time. Long before there was a mission called New Horizons, there was a small group of young scientists who had an idea, a dream, somewhere between an idea and a fantasy, that they wanted to send a spacecraft out to explore the planet Pluto. And I've known Alan since really about the time that this quest started in around 1989, and several of the other team members are dear old friends of mine I went to grad school with, and so I've followed this story for a long time, and I remember thinking many times over the years, I cannot believe what these guys are going through to try to make this happen. This is going to make a great book someday. I mean, seriously, years ago I remember thinking that, especially if they succeed, which seemed very unlikely at times, then that's going to make a great book because it's such an unlikely story of narrow escapes and doors being slammed in your face and then finding a way to keep going. And they started out young and had to really figure out how it works to go from an idea to an actual mission. And in telling that story of how they discovered, how they figured out how it works, I think if we've succeeded in what we set out to do, then we reveal to you how it works. And that's something we're really proud of because there are a lot of good books about space exploration, as many of you know. But I don't think there's another book quite like this that sort of peels back those layers and shows you what the people go through and experience and have to navigate in order to get to the point where you've gone from just an idea that you've had with some friends around a table at an Italian restaurant in Baltimore in 1989 to 26 years later, 1,000-pound spacecraft screaming at 30,000 miles per hour past the planet Pluto and snapping pictures and sending them back home. That 26-year journey has a lot of, I think, fascinating details that most people have never heard, and that's what we try to uncover in this book. It starts in a way before I get to where it starts, I wanted to share with you one little treasure, a preview of coming attractions. I had to at least show you one cool picture of Pluto from New Horizons, because this is where we're going to end up. But I couldn't resist jumping ahead, because this is what it's all about, is the beauty and complexity and wonder of this world, which was heretofore unknown to humankind until the summer of 2015. And in just this one beautiful shot, this is one of our favorites, you can see, just for scale, this landscape this is about 500 miles across. And you can see there's big mountains, there's a lot of topography. This is taken about 15 minutes after the closest approach to Pluto, so they're starting to look back a little bit towards the sun, so you can see there's shadows, which really reveals the topography. Some big mountains. Over on the right there, you can see there's some stuff flowing on the surface. There's been motion and activity. We'll come back to what that is. Off the horizon, you can see there are hazes in the atmosphere. So there's a lot going on here. It's a beautiful planet with a lot of scientific treasures. And like I said, we'll come back to that, but I couldn't resist showing you one teaser image. So now let's go back in time to really where the story begins. In 1930, with this guy, Clyde Tombaugh, an American hero whose story is one that we talk about in the book a little bit and is not well enough known because it's an extraordinary story. He was a poor Kansas farm boy during the Depression, hard times on the farm, was fascinated with astronomy. He was an autodidact, taught himself out of books from the local library, built his own telescopes, ground the lenses, and when there was downtime, when there wasn't too much work on the farm, he would go out at night and observe the sky and make sketches of Mars and Jupiter from what he saw through his telescope. And he dreamed that someday he would be an astronomer, but he had no plan, no ability to comprehend he would ever be able to afford to go to college and actually become a professional astronomer. But he took those sketches he made and he mailed them off to observatories around the world like messages in a bottle. Well, who knows who will find them. And then one day, a letter comes to Clyde's farm from the Lowell Observatory in Flagstaff, Arizona. And it says, "Dear Mr. Tombaugh, we have seen your sketches. We received your sketches of the planet Mars, and we're very impressed with your work. We are hiring an assistant astronomer. Would you be interested in the position?" You know he was. And with that, Clyde, almost for the first time, left Kansas and got in a train with his mother, packed him some sandwiches for the journey, and he had his astronomy books in his suitcase, and he went to Flagstaff, Arizona, in the mountains of northern Arizona, and began a long quest to find what was then called Planet X, a search that Percival Lowell had started a quarter century earlier, and nobody had been able to find it. And that's what he was hired for. And night after night, he would go up to the telescope and photograph little patches of sky, and then photograph them again a few days later and blink between the two to see if anything was moving in just the right way to indicate an object out beyond the orbit of the then farthest known planet, Neptune. And over a year, Clyde did this, and a lot of senior astronomers told him it was futile, he was on a fool's errand. It had already been searched for enough, there was nothing out there. But after more than a year, in January 1930, Clyde found something. And this is blinking between the nights of January 23rd and January 29th. And you can see most of the objects, most of those dots are the same between the two nights because those are the stars. Don't move from night to night. But this little flea jumping across the plate from here to here, that's what he was looking for. It was a faint object moving in just the right way to be orbiting beyond the orbit of Neptune. He was pretty sure he'd found it, but he went back the next month after the next full moon to search again, and it was in exactly the right place. And then he knew. And for a very short while, Clyde Tombaugh was the only person on Earth to know about this whole world out there. And then he went, knocked on the door of his boss and said, "Dr. Slifer, I have found your Planet X." And he had. And then they needed to name it and announce it to the world. They announced it to the world, and then suggestions poured in from around the world for what to call this new planet. And we list some of them in the book. There were some kind of goofy and funny and weird and cool suggestions. But a really great one came from an 11-year-old girl in England, a schoolgirl, who suggested this name, and her father wrote a telegram to Lowell Observatory. This 11-year-old girl, Venetia Burney, suggested that this planet be called Pluto, and that was the name they decided to give it. So that's the beginning of this story, and one thing that I find remarkable is that that's pretty recent, 1930. There's still a lot of people alive who were alive when Clyde discovered Pluto. It's a story of our time, really, and this leads us then a couple of decades later into the space age. And that's sort of the next place our story picks up. And we talk about the inspiration that space explorers of our generation, Alan and I both grew up in this time where the Apollo missions were, the amazing thing that was happening when we were kids. And seeing that on television, Neil and Buzz, hopping onto the moon, that was mind-blowing. And a lot of space scientists of our generation will tell you that that was the moment that something clicked and we got set on a trajectory. Also happening that same decade were the first missions to the other planets, to a lot of the other planets, and that was mind-blowing for a kid in the 60s and 70s. For instance, this is the spacecraft Mariner 4, which was the first successful flyby that returned pictures of the planet Mars, like this one here. And that was amazing, seeing that there were spacecraft going to planets for the first time. And the first time you get to a new planet, it's always a flyby. And a flyby is a particular kind of exciting discovery because it's in a moment, in a few hours, a planet goes from this blurry thing that you've seen in telescopes and know very little about to this place that you've all of a sudden seen up close. It's a burst of revelation. There's nothing like the first flyby of a planet. There are a lot of cool kinds of missions, orbiters, landers, rovers, that are neat in different ways. But a first flyby, it just packs this world of discovery into a day, into a few hours when the spacecraft goes screaming past. And by the way, this flyby of Mariner 4 by Mars, returning the first close-up pictures of Mars, happened on July 14th, 1965. Now remember that date. It'll become significant a little bit later this evening. In August of 1970, this issue of National Geographic was published. And Alan remembers this, I remember this, a lot of kids our age remember this, because it had this cover story, Voyage to the Planets. And on the cover you can see there was this artist's depiction of Saturn as seen from Titan. It had to be an artist's depiction because nobody had seen Saturn close up. And we know now Titan doesn't look like this, but it was a reasonable guess at the time. And this story, Voyage to the Planets, it talked about the planetary missions that had already happened in the 1960s, the early missions to Mars and Venus and Mercury. Well, no, Mercury didn't really happen until the early 70s, right after this. But the first planetary missions, and it profiled the first generation of planetary explorers. It had pictures and stories about Carl Sagan and some of his colleagues. And it just seemed like the coolest thing in the world, that people were actually doing this for a living, exploring new planets. And in that same issue of National Geographic, you know, they were talking about the missions to come in the 1970s and 1980s. And then there was a chart that summarized what was known about all the planets. One for each planet, and then boxes that told you, summarize the information known, their orbits, what temperature they are, what they're made out of, how big they are, all the facts about each planet. And over on the far right of this chart, of this table, there was a column for Pluto. And underneath Pluto, all the boxes said, question mark, question mark, question mark, question mark. It was a mystery world, and it really stood out in comparison to the other planets in this issue. It was the place we knew nothing about. And that opened the door for a lot of interesting kind of lore and fantasy and speculation about Pluto, and there was some fun science fiction from that period, from the 70s and 80s. And Pluto was always this kind of, outpost planet, the farthest outpost, the gateway to the stars. Or in some stories, Pluto had mysterious alien artifacts. Because the fact is, a place that you know nothing about is you're free to speculate wildly and you're not contradicting any known facts. So Pluto was a good, it was a blank slate on which we could inscribe our fantasies. But there was also the idea that maybe we could change that. And in that same National Geographic issue, they talked about this opportunity that was coming up in the 1970s for a grand tour mission, a mission concept they called the Grand Tour. The idea was if the planets line up just right, which it turns out they only do every 180 years, then you could launch from Earth and swing by Jupiter and do a gravity assist by Jupiter, where you use Jupiter's gravitational pull to fling you on towards Saturn, and then you go to Saturn and you use Saturn's gravity to fling you towards Uranus, and you can go to Neptune and maybe on out to Pluto. And it just so happened that later in the 1970s, the planets were going to be lined up in just that way that we could do a grand tour, and then it wouldn't be that way again for another 180 years. And that was actually, if you think about it, kind of an amazing stroke of luck. If you think of the species on Earth getting to the point where they've got the technology and the ability to launch spacecraft off of the planet in the 1960s, and then the very next decade, this sort of gateway to the outer solar system is going to open up, which only happens once every 200 years. So that was sort of lucky, but then there was the question, will we be able to mount such a mission and take advantage of the Grand Tour trajectory? And there was some drama there, but ultimately that turned into the Voyager mission. And Voyager was this incredible adventure, launched in 1977. There's one of the Voyagers, there were two of them, got to Jupiter in 79, Saturn in 80 and 81, Uranus in 86, and Neptune in 89. And for those of us who were young students and young scientists in that era, the Voyager encounters were amazing because they were these first flybys of these planets and all these moons were, just these bursts of discovery. And there was sort of one every few years. So during the 70s and 80s, you can always count on, there being another Voyager encounter coming up in a few years where the tribe of planetary scientists would gather at JPL in Pasadena, and another wonderful encounter would happen. But then in 1989, with the Neptune encounter, it was all over. Neptune was the last planet Voyager 2 visited, and this is one of the last pictures of a crescent Neptune because you're leaving Neptune and looking back towards the sun. And off the edge of a crescent Neptune, you can see a crescent Triton. And Triton was one of the last places Voyager uncovered for humanity. And Triton is an amazing place, one of the best places Voyager explored, an icy moon of Neptune that in some ways is actually very Pluto-like. It's roughly the same size. On the surface, there's nitrogen ice and methane ice. There's geological activity that was surprising. There were geysers. There's a thin atmosphere. And Triton was just wonderful, and it whetted a lot of people's appetites to start wondering about Pluto and wondering about other icy worlds out there. But there was something sad about the Voyager-Neptune encounter because it was the last one. And for a while, it seemed like maybe it was all going to be over. Was that going to be our last ever encounter with a new planet in the solar system, our first flyby? There was something poignant about it. But this is where my co-author, Alan Stern, enters the story, because right around that time of the Voyager-Neptune flyby in 1989, Alan, fresh out of grad school, was thinking about the possibility of sending a mission to Pluto. He and a small group of cohorts asked, why do we have to stop here? We sort of missed out on Voyager, those of us right around that time, Alan and others who were just getting their PhDs around then. What's our mission? What's our Voyager? How can we keep going and explore new places? And they started to talk about a Pluto mission, but at first it was a very unlikely idea, and they had to really fight an uphill battle with a lot of surprising twists and turns. And I'm going to bring Alan on in just a second to tell you more about that, but first I have to embarrass him for a second with one image. This is a young Alan Stern with, in fact, his first scientific instrument. And you'll notice that here he's looking down, but soon after this he decided that what he really wanted to do with his scientific instruments was look up, and he's still doing that. And right now it's my great pleasure to introduce my colleague and co-author, Dr. Alan Stern. Use that as a pointer on that.
Great. Okay, great. Thank you very much, David. When we first put this presentation together, David surprised me where did he come up with this slide? So I really couldn't stand it, so I thought I would come up with a slide of David. Right here, almost as young, but you notice he's not with his first scientific instrument, but he is with his first scientific mentor, Carl Sagan, who was his father's best friend. They were both young professors at Harvard. David grew up with Carl in the house. It's not a surprise that he's such a spectacular writer and has done such amazing books like Venus Revealed, Earth in Human Hands, and now Chasing New Horizons. So I want to tell you a little bit more about this story, and I want to start off with what we call in the book the Pluto Files, or the Pluto Underground. This is a committee which I chaired when I was about 12 years old. In the early 1990s, when we all dressed funny and wore neckties, or most everybody, some people were ahead of their time. But this was a committee called the Outer Planets Science Working Group, which was charged with examining how various ways we could go about flying missions to go explore Pluto. Back in 1989, I had been drafted from this Pluto Underground group to march up to NASA headquarters and ask a man named Jeff Briggs, who ran the Planetary Exploration Program, if we could get a study together of how to send a spacecraft back all the way out there where Voyager had gone, and even further. And we did that. I was the study scientist for it. It was something called Pluto 350. You'll read all about it in the book. And it was quite a revolutionary study for its time. But then following that, NASA got serious. They made this Outer Planets Science Working Group and started putting more money into more development of the ideas behind how you could go about doing that. As it turned out, this is a picture taken in 1991, April of 1991. We had no idea what was in store. We had had a pretty easy start. Briggs said yes. Briggs put some money out there. The Jet Propulsion Laboratory down in Los Angeles and a science team that I had formed got together. We produced a study. It showed that it was feasible. And then this group got formed. But what we had no idea was that it was going to be another 12 years before NASA would start actually funding a mission to Pluto. And year after year, fashions would change. Try a really big mission to Pluto. Try a really tiny mission to Pluto. Try and do it without nuclear power, which is impossible to go that far from the sun and use solar arrays. Try this, try that. We had mini reversals. We had dead ends. We had blind alleys. We tried going to Russia to get free launch vehicles. We did. This is before Russia was off the table like it is today. And the book spends perhaps 50 or 60 pages and tells you about this crazy maze we were in Washington politics, where we always felt like this, right? We were Charlie Brown, and Lucy was constantly stealing the football. Sometimes a study was poorly managed. Sometimes the results had they cost too much. They tried to pack too much in. Sometimes it was just an infeasible dream of building a spacecraft that was so tiny that no one could possibly make a mission like that all the way to the outer solar system. And other things happened. They came out of the blue. In 1993, a mission was approaching Mars called Mars Observer. 4 days from reaching the target, it blew up. Just went off the air, exploded, literally. And NASA decided that they should take that money, which it was just about to be for a new start, to fund a Pluto mission and replace that spacecraft for Mars, which they did. So it was Lucy and the football all through the 90s. And the thing about that, and the book brings it out, I think, pretty well, for the people who worked on this, it took a lot of stamina, determination, and drive. It took persistence. It's not so bad when the first time it didn't work out, you say, well, we need to try something else. And the second time it doesn't work out, you say, well, third time's the charm. Except it got to be the 6th, 7th, 8th, 9th, and I have now said more than once that if Pluto missions had been a cat, they'd have been dead long ago. Cats only get 9 lives. But eventually, something very important happened. And that was the discovery of the solar system's third zone. So in this diagram, the white ovals are the orbits of the giant planets. The sun is in the middle. The planets like Earth and Mars, their orbits are so close to the sun you can't see them in this diagram. That inner circle is Jupiter's orbit, then Saturn, Uranus, and Neptune. The yellow one is Pluto. And when Clyde Tombaugh discovered Pluto, he and others went looking. What else might be out there in the distant reaches of the solar system? They couldn't find a thing. And they looked in the 30s and the 40s and the 50s and the 60s. The technology got better. They looked in the 70s and the 80s. They couldn't find a thing out that far. Just Pluto. It seemed like a misfit. Didn't look like a giant planet. Didn't look like one of the rocky terrestrial planets. But then the floodgates opened in the 90s with much better computer technology to actually scour images, and with CCDs instead of plates, instead of photographic technology. One object orbiting out there beyond Neptune in an orbit not that different from Pluto's was discovered in 1992. It made the cover of Nature. The next year, 4 more were discovered. In 1994, another 10. And by the end of the decade, more than 1,000. They form the solar system's third zone. This belt or disk of material we call the Kuiper Belt, after Gerard Kuiper, who most famously predicted its existence way back in 1950 and 51. Now, this belt is the source of all the short-period comets in our solar system. But more importantly, it revolutionized our knowledge of the geography of our solar system. We used to think of the terrestrial planets like Venus and Mercury and Mars and the Earth as the inner solar system. Now, that we still do. We thought of the giant planets, Jupiter, Saturn, Uranus, and Neptune, as the outer solar system. We called Voyager an outer planets mission. With the discovery of the Kuiper Belt, it was realized that the giant planet region is really the middle solar system. This is the true outer solar system. This region is larger, and I don't think this diagram does it justice. It's actually larger than everything from Neptune down to the sun by a factor of 7. It completely dominates the architecture of the solar system. And in addition to all those comets and somewhat larger objects the size of counties or New England states that we call planetesimals, that are building blocks of larger objects, we started to find objects close to Pluto's size, small planets. And today they have names like Ixion and Haumea and Sedna and Eris and so forth. There are a dozen of them that are now known. This is a fundamental paradigm shift in our field, is we realized there was a third class of planet in the solar system, and that class of planet, the small ones, the size of continents on the Earth, but not the size of the Earth, actually dominate the planetary population of our solar system. There are more small planets in the Kuiper Belt than all of the 4 giant planets and 4 terrestrial planets combined. And with that realization, the National Academy of Sciences rocketed the priority to go to Pluto to the very top of the list in 2003. Because you see, then, beyond just studying this fascinating system, the Pluto system, with all of its interesting properties, Pluto represented an archetype for this entire new class of planet. And so by going to Pluto, we could not just explore Pluto, but begin to explore the third zone of the solar system and this new type of planet. And with that came the money to actually build the spacecraft. And NASA held a competition. It was very steep. There were 5 teams that each wrote proposals about this thick, like an old New York City phone book, with engineering designs, scientific instrument designs, cost and management and schedule for how to carry out the entire project. 5 teams competed. NASA narrowed it down to 2. We were one of the 2, the New Horizons team. And ultimately, the New Horizons team, which as we described in the story, was really the David in a David versus Goliath battle. Because the Jet Propulsion Laboratory was our opponent in this, and they had done all the exploration of the planets previously. Our team had much less experience, but we wrote a better proposal. And NASA selected us, and this is the spacecraft that we built, New Horizons. We were selected in November of 2001, and we were really challenged because although we were approved to go and do it, we needed to use Jupiter as a gravity assist to fly to Pluto. And there was only one remaining Jupiter gravity assist in the entire decade of the 2000s. And somewhere between God and Mr. Newton, that schedule was fixed. In January of 2006, there was a 3-week launch window. And if you miss it, you wait about a decade to fly it again. So we had to build that spacecraft, to design it and build it and test it and have it on a rocket and ready in 4 years and 2 months, which is lightning speed for a project like this. The Voyagers were 8 or 10 years in development. And to make matters even tougher, the budget that NASA allocated for the New Horizons team to do New Horizons was 1/5, 2 dimes on the dollar compared to Voyager. So we had severe schedule challenges. We had to figure out how to do this more than twice as fast and for 5 times less money. When we won, I got a lot of congratulations, but I got a lot of phone calls from colleagues that said, "You won, but you lost." Because you're going to work on this, you're going to work 7 days a week, you're going to work your heart out, you and your team, and somewhere along the road, you're not going to be able to meet schedule, or you're not going to be able to meet cost. It's going to get canceled. It's too high a bar. You'll never make it to the launch pad, and it'll be a stain on your career for the rest of your life. That was just great. Anyway, that's not what happened. The New Horizons team actually buckled down, made some compromises, figured out how to do this more quickly and much less expensively, and actually produced this spacecraft. Here's a picture of New Horizons in Florida at the launch site in a clean room in late 2005, barely a month before we put it on the launch vehicle. And I just want to give you a little quick tour of the spacecraft. There's some people for scale. It's a very small spacecraft, and intentionally so, because by building a small, lightweight spacecraft weighing only about 1,000 pounds, about the size of a baby grand piano, and putting it on the biggest rocket anyone would sell us, you could get the fastest speed to cross the solar system in the least amount of time. And that was our objective. Now, inside this spacecraft, inside the box, if you will, we call it a bus, inside of there are all the systems that you need for the journey. Guidance systems, propulsion systems, thermal control, power distribution, main computer, communications, guidance computers, all that, and we carry 2 of each because we only had the money to build 1 spacecraft. This is not Voyager 1 and 2, where there's a backup. There's no chance for a redo. If something breaks, we need to have backup systems on board. So there are 2 transmitters and 2 sets of thrusters in every direction, 2 guidance computers, 2 star trackers, 2 sets of gyros, and on down the list. Almost everything on board, except for structure and this funny-looking hair curler, is twinned. And it all fits in this small package. Up top is a dish antenna a little bigger than 6 feet across. That's we call it the high gain antenna, but it's our dish to communicate back to the Earth, to transmit and to receive. And then this thing that does look like a hair curler is actually a nuclear power generator called an RTG. It stands for radioisotope thermoelectric generator. It's fueled with plutonium, radioactive plutonium, which, by the way, was discovered in 1938 or 39 and was named for the planet Pluto. It's true. Back in the 30s, they had a fashion, they were naming elements for planets, uranium, neptunium, plutonium, etc. So we actually sent plutonium back to Pluto. Thank you. The way this works is that you bottle it up in this black cylinder. You bottle up the plutonium. It's generating about 5 kilowatts of heat. And through clever thermal design, the inside of this skin is very hot with that 5 kilowatt heater going on. But these fins that are radiators cause the outside of the skin to be very cold, near absolute zero. And if you put thermocouples across the temperature gradient, it drives a little current. It's not very efficient, only 6% efficient. So the 5 kilowatts turns into about 250 watts of DC electricity that has to run all the systems on board. I bet you each of these lights is probably more than 200 watts, right? This is 3 garden variety light bulbs to run everything, including the 7 scientific instruments. But this is the spacecraft we built. We did do it on cost. We did do it on schedule. This was November of 2005. The launch window is now 6 or 8 weeks in the future. And we had it all together. This is a little bit more detail on the spacecraft, but I think I've said most of the things that are here. So let me move right along and say that as we were getting ready to fly, there was one more thing that we wanted to do. Back in the 90s, when we were first studying how to fly a mission to Pluto, Clyde Tombaugh was still alive, the man that discovered Pluto. He knew that plans were afoot and people were dreaming about how to go all the way back out there and study his planet. But he died in January of 1997 at the age of 91 years old. Before he died, he had said to some of us working on those studies, if you ever get this together and there's a way to do it, I'd like to have my ashes aboard that spacecraft. And so it got to be 2005, and it was looking pretty likely that we could pull this off. And so I called his widow, Patsy, up and had a kind of a delicate conversation and asked if Clyde had maybe ever mentioned that he might like to fly to Pluto. He'd said that. Whether maybe had he been buried or were there ashes? There were. Would the family like us to do that? They would very much. And they sent those to my office in Boulder, Colorado. And I put them in my briefcase, and I flew out to the Johns Hopkins Applied Physics Lab where the spacecraft was being built, and had a meeting of our engineers, and I said, now how are we going to do this? We got to get this aboard the spacecraft. It's a late edition. They said, oh, this is easy. We'll make a balance weight out of it, and we'll replace one of the balance weight with Clydes Ashes. You know the engineers, everything's got to have a purpose. It's fully engineered. So that's what they did. We put it in this little cylinder, and then I wrote an inscription that's on it, and I can't read it from this far back. It says, "Interned herein are the remains of American Clyde W. Tombaugh, discoverer of Pluto and the solar system's third zone. Adele and Muron's boy, Patricia's husband, Annette and Alden's father, astronomer, teacher, punster, and friend, Clyde W. Tombaugh," and his dates, 1906 to 1997. And we launched him to the stars just barely a month later. Pretty amazing. Now, every space flight requires a team of people. Space flight's a team sport. You don't know this, most of you don't know this, but 2,500 Americans worked to build New Horizons, its launch vehicle, and its nuclear power supply. Mostly worked in anonymity. Imagine that, 2,500 men and women did this project, and you never heard about it. But that teamwork is what got us there. All these people were working to see America fly this mission at breakthrough cost all the way out to the edge of the solar system to explore the last of the classical planets known at the birth of the space age. America had been first to every planet in the solar system. Not in this order, but all the way from Mercury, closest to the sun, all the way out to Neptune. There was a little unfinished business at Pluto. In fact, back in 1991, when we were first working on this, the post office wanted to commemorate the success of all those early explorations, and Voyager just finished, so they issued a set of 9 stamps for the exploration of the planets. And they had the first mission that had explored each planet, Mariner 4 to Mars, as David said, Mariner 2 to Venus, Mariner 10 to Mercury, Pioneer 10 to Jupiter, and so forth and so on, and a picture of each planet from those first missions, except for Pluto. They had to have an artist's conception, and it just said, "Pluto not explored." It was pretty lame, but it became a bit of a rallying cry. So, in fact, in addition to Clyde's Ashes, I also had us paste one of those stamps on the spacecraft to fly it in Pluto's face and get it canceled. That's true. Now, after we launched, we didn't need 2,500 people. We didn't have to build a big launch vehicle or a spacecraft. We didn't have to have all those test facilities. We didn't need a crew to build nuclear power generators. And after launch, it necked down. It went from like running New York City to being mayor of Hooterville. It's 50 people. Less people than just in this one section for the science team, the engineering team, the flight control team, the project management, public affairs people, everybody. Just 50 belly buttons. This is a picture of the flight team taken just 2 weeks after the flyby of Pluto. We were in a pretty good mood, can you tell? Right? But I wanted to show this picture because it's all about teamwork in spaceflight. And I also wanted to use this opportunity to tell you that some people who worked on New Horizons as science team members, on the NASA side, on the project management, even on the educator public outreach side, are in this room with us tonight. And I'd like them to stand up. Would you please all stand up if you're part of the New Horizons team? Don't be shy. Ross, thank you, everybody. Whoops, we don't want to do that. I hope I can back that up. I sure hope I could back that up. Anyway, so thank you very much for that. An amazing effort by our entire team to build this spacecraft and get it to the launch pad, and then to fly it across 3 billion miles of space flawlessly. I doubt I'm trying, but I wanted to back up and show one slide. Well, let me just say this, what was on that slide. I want to talk about this launch vehicle, the Atlas V. This is the Atlas 551. It's the most powerful launch vehicle that was then available in the US inventory. And to make our journey to Pluto as fast as possible, we completely tricked it out. We bought every upgrade, every option, the most number of solid rocket boosters, the lightest weight nose cone. We put a special purpose third stage nobody had ever loaded up there before. really, it was amazing. And particularly for me, you know, I was a kid that built Estes model rockets and would mow lawns and wash cars so that I'd get bigger and bigger rockets. You have no idea how much fun it was to order this baby. And that nose cone, it's 70 feet high. And it's built to launch moving van-sized spy satellites and space telescopes. And here we put little New Horizons in it, about twice the size of this podium. And I remember going in that nose cone. We're launching this baby empty, which of course was the purpose, right? It was just, I took to calling New Horizons the hood ornament on the Atlas. And then on our third launch attempt, and we walked through that whole story in chasing New Horizons, we actually launched it on Thursday, the 19th of January, 2006. And hopefully we can play this video, but it might just be stuck. It's going to work.
Status check.
There we go. So this is 224 feet tall. It's as big as a skyscraper in the city, downtown San Francisco. Can we turn the sound down a little bit? Now watch how fast this skyscraper gets off the launch pad. It's going to reach that cloud deck 2 miles high in about 15 seconds. If you've never been to a launch of something like this, you really need to take time and go to Florida and do it, because we can't do the acoustics justice by being here. Now, watch it. There it is in the clouds, 2 miles high, downtown building. And in under 30 seconds, this monster went supersonic. We have 7 rocket engines, all firing in tandem, 5 solid rocket motors, 2 liquid propulsion engines to take this baby up to hypersonic speed. Now, shortly, the solid rocket motors are going to run out of fuel. And then they're just dead weight, so we want to cast them away so the vehicle can accelerate faster. And that's what you're going to see right here. You'll see 2 separate, and a moment later, the other 3. There you go, 2, 3. Now we're free of all that dead weight, and the sustainer liquid propulsion system can really now start hauling the mail, because the job is to get this whole stack up to orbit in about 8 minutes, going 18,000 miles an hour. And in fact, we're already at space altitudes. I haven't been talking for more than 90 seconds, and we can shed the nose cone now because we don't need it. We're above all the air. And there it goes, and behind that cloud, and that was the last anyone ever saw of New Horizons. We've been flying it for 12 and a half years. We've never seen it ever since. We just talked to it by radio. And we flew across the solar system. That's easy to say, but it took almost a decade. Now, this was a really fast spacecraft, the fastest spacecraft ever launched. How many people here remember that when Apollo missions launched to the moon, 25,000 miles an hour, it took 3 days to get to the moon, right? New Horizons did that in 9 hours. We fly almost 1 million miles every day. We do that 7 days a week and 52 weeks a year. 13 months after we launched, we were at Jupiter for that gravity assist, 500 million miles away. Previous spacecraft to do that job had taken 4 to 6 years. We did it in 1 year and 1 month. And during that 1 year and 1 month, we were super busy because we had to completely check out all the spacecraft systems, all the backup systems, and then commission all 7 scientific instruments, get them calibrated, navigate to the aim point at Jupiter that took us to Pluto, because if we don't go to that aim point, we're going somewhere else in a hurry, but it's not going to be a Pluto mission anymore. And then at the same time, we had to plan a Jupiter flyby because this was our only chance, the only thing we passed along the way. So we wanted to test all the flight software and all the flight systems to work out all the bugs so that at Pluto, we only learn about Pluto, not our spacecraft. Seemed like a good plan. So we did that, and we flew past Jupiter in, which one is it? February of 2007, and then launched on an 8-year crossing of this ocean of space from Jupiter to Pluto, 2.5 billion miles with a B, like Carl Sagan used to say, billion, right? Traveling almost 1 million miles a day. And I know people used to ask us on the team, what do you do while the spacecraft is, you know, and I hear it's hibernating. What do you guys, you're waiting, you're bored? It must be terrible just waiting and waiting and waiting. That wasn't the case at all, because we only had these 50 people, And yet we had to do the same work that the Voyager team, they had 450 people. And we had to plan the flyby of Pluto down to the nth detail. What flyby altitude, which day we're going to arrive on, which satellites we're going to fly by, which instruments look at which targets in the system at which time, how we operate them, which modes, what commands to send, where to store the data, which recorder to put it on, and 100 other details. Is it fit within the power budget? Is the thermal conditions on the spacecraft right? Do we have time to make the turn to that target? It's a huge, huge, complicated game. And all the while, we had to take care of the spacecraft and train the team for the flyby and write malfunction procedures for over 160 possible problems we might have to deal with in mission control. And along the way, we started finding that Pluto had not just one satellite that had been known when we started building it, but a second, a third, a fourth, and a fifth. And as a result, we started worrying about hazards because those small satellites could generate rings in principle, and we're flying through the system at 32,000 miles an hour. If we were struck by a single pellet the size of a rice pellet, whether it's made of ice or rock, game over. It would shred the spacecraft. So we had to design a program of imaging as we approached the planet to look for hazards. Then we had to have on the shelf 3 other flybys at different distances from Pluto, all ready to go, because there's no time to develop them if you have to do a divert maneuver. And so our team, over those 9 years, was working round the clock. Alice Bowman, who I'll show you a picture of shortly, Alice Bowman, who ran mission operations, called it a 9-year sprint, right? I can't tell you how many meetings I went to where they said there's too much work. Meanwhile, my parents and everybody else were asking, what are you doing? Aren't you bored? It's not still 7 years till you get there. Anyway, we did do all that. This is Alice Bowman. She's the mission's mom. That stands for Mission Operations Manager. Well, you're laughing. Every robotic spacecraft to the planets has a mission operations manager, and they're always called a mom, whether it's a man or a woman. How many people here saw Apollo 13, the movie? Almost everybody. That's good. Okay, you remember the part that Ed Harris played in Mission Control? He was the flight director, the boss of Mission Control, with the flat top and the vest, right? That's Alice's job. She ran our Mission Control. She still does. She's been on the project since we wrote the proposal. She designed it, or her team designed it. They wrote all the software to drive the spacecraft and their mission control during the years we were developing the project. And she has led the flight of New Horizons across the solar system. And she's got a team of men and women, about 50-50, that are the flight controllers and the engineers that operate this interplanetary spacecraft. Now, 10 days before we got to Pluto, this team was tested in a way that few teams are. It was July the 4th, 2015, a holiday. We had given almost everybody the day off. But that morning, we had launched the long command load that went up to the spacecraft with a sequence for the flyby that was supposed to begin in 3 days. It took 4.5 hours, the speed of light, for that command load to cross the solar system. And then 4.5 hours later, as the signal was coming back to Earth, reporting how well that went in terms of storing all that data, with no warning, the spacecraft went offline. We're getting ones and zeros, and then and they checked, has something happened to the antenna station in Australia? Did they move the antenna? Did they have a failure in the receivers? None of that. The spacecraft had gone offline. Immediately, the first thing you do in that situation is you start calling everybody on the team. My cell phone rang. It was a project manager. I knew he was at a barbecue. Probably not calling to tell me how good that sauce is. Why is he calling? Pick up the phone. Alan, we've lost contact with the spacecraft. Now, we're 3,300 days out of the box. We've been flying for 3,300 and some odd days. Things had never gone bad on us. And today, 10 days before Pluto flyby, all of a sudden, we lost contact with the spacecraft. When that happened, that one going to Mars, they never heard from it again. This is a very serious situation. I said, Glenn, I'll meet you in Mission Control. And 4 minutes later, I was there. I had to drive the car across campus, flash my badge, go through security, upstairs to Mission Control. When I got there, people were already coming in from their picnics, and their family activities. So this is a high-tech mission control, and people are coming in flip-flops and tank tops and, you know, crazy T-shirts and all this, and they didn't know it, but none of them were going to leave for days. It was just like in Apollo 13, the movie. Remember, they were sleeping on desks, and they were eating from the candy machines and all that. That's what happened here, because what we found when we got communication back with the spacecraft is the main computer had been overloaded. And this whole story is told in great detail in our book. In fact, the book opens with me getting a phone call 10 days from Pluto, and we lose the spacecraft. And we don't tell you how it ends until much later in the book, after we tell you about Clyde Tombaugh and, you know, why we had a mission to Pluto and the whole challenge of raising the funding and building the mission, competition, flying it across the solar system. And we found out that when we switched to the backup side, all of the files that instructed the spacecraft how to do the flyby had been erased. Just like when your computer goes blue screen and you bring it back up and that Word file you've been working on is gone, right? And we had been putting various files up on the spacecraft in the memory since December. It's July, for 6 months. Been loading up pointing files and ephemeris files and orbit files for each of the satellites and the big instruction load for how to do the flyby, and they're all gone. Dozens of files. We've been doing this for months, and now we've got 3 days. We had 78 hours until flyby begins to figure out how to put it all back, to put Humpty Dumpty back together again. And obviously you know, because you've seen the cover of our book, there's a very nice picture of Pluto, that we figured it out. These guys went round the clock and figured out how to repeat those 6 months of work. And the stakes were very high, because every time we'd want to send instructions to the spacecraft, there's this 9-hour round-trip flight time. So you're making these chess moves 9 hours at a time. There aren't that many 9-hour cycles per day, are there? In only 3 days. And believe it or not, they did it flawlessly and got us back online and rejoined the original timeline with 4 hours to go. They ought to make a movie. So, credit to Alice and her team. Let's see if David's slide, there we go. I want to talk to you about navigation. In order to do the science of New Horizons, there were some very stringent requirements on the spacecraft in terms of navigating to the planet. First, we had a very high priority objective of studying Pluto's atmosphere, and to do that, we had to fly through the shadow. So this is the intended spacecraft trajectory. These are the orbits of the satellites. The reason that they're up and down vertical is because Pluto's pole, like Uranus's, is actually tipped on its side. So we came at the system perpendicular, and we're aiming to fly through that shadow. In order to do that, we had to fly through one little window in space that's 40 by 60 miles. That's a big barn door. That's the size of the Bay Area, isn't it? Except it doesn't look very big from 3 billion miles away back at Earth, right? And somebody actually did the math for us around the time of the flyby, and it works out to a hole-in-one from LA to New York City. And our navigation team did that. In fact, they flew us right down the middle of the corridor. It was just an amazing job. And we were taking images on the way in and comparing where Pluto was to where it should be against the star fields and computing the difference and burn solutions for the engines for how to correct back on course. And we were homing in the whole way. But it wasn't just that we had to fly through this window in space. We also had to know what time it was. We had written this entire program, which was dependent upon knowing where each satellite and the planet was at every moment in time as we walked through the system so that we could point the cameras, because we're pointing blind, and the targets better show up in the field of view. Not half of it, or an empty frame, but exactly in. And they calculated for us that to do that, we had to arrive within 450 seconds of the intended time that was set at launch, after 9.5 years. And we did it. New Horizons arrived at Pluto 86 seconds off the intended time after that 9.5-year journey. 86 seconds early. Now, David and I just flew in to SFO Airport from Houston, Texas, a 4-hour flight, and it was much more than 9.5 minutes. off schedule. So that's a pretty good feat to do that after 9.5 years. And they completely pulled it off. And I don't know how many of you might have been at the flyby, but for our team, it was unbelievable. Thousands of people, and David describes this in the book, thousands of people came to be at the flyby. And literally, politicians and rock stars were showing up, and movie stars, and the highest NASA brass. And it just became kind of a Woodstock event for science. Well, minus mud and drugs, but it was really an amazing confluence of people. Literally thousands of people descended on mission control and stayed there. And the whole thing was put on the web, and an unbelievable response. 2 billion web hits in 24 hours. I promised my mom was less than half. But we had 200 press show up. NASA hadn't seen anything like this since the days of Apollo and Voyager, because people love exploration. And these are scenes from Mission Control. You can see it's kind of bedlam in some of the scenes. Even better, when we found out that it all worked, it was crazy emotional. This is a scene in Mission Control just moments after Alice had gotten the telemetry report that everything had worked, the memories were full of data on Pluto. We were outbound from the Pluto system, and I had been back in this room observing Mission Control with the NASA administrator, and I just couldn't resist. It was time for a hug. But it was more than just that. This is a picture of our science team that morning, a few hours before, when the first high-resolution image of Pluto was cast up on the big screen, 5 a.m. And here are people, many of them had worked 15 years. Some people on the project, like me, had worked 26 years to see this dream we had come true, to be a part of something larger than life, to explore the farthest worlds in the history of humankind, to be the first to this new zone of the solar system, this new type of planet. And look at the emotion in that room. Dale Cruikshank was there. Ross Beyer was there. A couple of other people in this audience. I think Dennis Bogan was there. And, there were fist bumps, and there were hugs. There were people jumping up and down. There were tears. There were shouts. There were high fives. It was everything you could imagine, because it had all come together, and perfectly. We did over 450 observations in the Pluto system after we got all the data back on the ground. Every single one perfectly correct. Not a single one had a problem. So I want to show you a little bit of what we brought home. I'm going to start with a family portrait of Pluto and some of its satellites. Right here, there's Pluto. For scale, if San Francisco was here on the western limb, go all the way across to the eastern limb, that's somewhere in Ohio. So this is a pretty big place. You wouldn't walk across it. It's got about as much surface area as the entirety of the United States, including Alaska. This is the biggest satellite, Charon, the one discovered from the ground in the 70s. These are 2 of the 4 smaller satellites, Nix and Hydra, they're called. And then there are 2 more, Kerberos and Styx, are not in this family portrait, but they're shown here. Here are all 4 of the small satellites that orbit the binary, the 2 big guys, in order of their distance from Pluto. Styx is closest, Hydra's furthest. And all of these were named in the mythology of the underworld that Pluto is named after. I know a lot of people think this was just for a bad 70s rock band. Not true. We learned a lot about these guys. Really, they were just points of light before the flyby, but we fingerprinted their composition with our spectrometers. We can see geology in the highest resolution images. We can see interesting color variations on the surface. We've, in an indirect way, measured their masses. We can infer their densities by knowing their volumes. And really, nothing was known about them to speak of beforehand except their orbits. And here they are compared to the big satellite, Charon, for size. So, but they're not the star of the show. The star of the show is this strange binary planet called Pluto-Charon. Pluto in the front, much brighter and more colorful because it's got all these interesting ices on the surface made of nitrogen and methane and carbon monoxide. And at the relevant temperatures, they can actually move around the surface and through the atmosphere. and make for complex seasonal cycles. And then the kind of dullard sister Charon in the background, which is much darker and less colorful by a long shot. A little bit more about Charon here. This is a close-up. Everything you're looking at, just about everything here, is just water ice. The entire surface. And in fact, 50% of the mass of Charon is just water ice. See all these craters? We can use these craters to date the age of the surface. And if you don't know how that's done, it's actually conceptually very simple. Imagine it was raining outside, and we went outside with a piece of paper. The longer you leave it out in the rain, the more dots will appear. Well, it's raining impactors in the Kuiper Belt. And the longer you leave a surface out in that rain of impactors, the more craters will accumulate. So a more heavily cratered surface is older. And if you can't find craters, it must be very young. So it turns out this surface is 4.5 billion years old, basically as old as the solar system, meaning that Charon, after its formation, quit evolving very early. And it's just been out there in the rain of impactors. There are other interesting things. All the way across the equator, here's the North Pole, all the way across the equator is a big canyon system that geologists call an extensional tectonic belt. Ross Beyer, raise your hand, just submitted a paper about this. Apparently what happened is the interior was warm with water, liquid water, when it first formed. And as it cooled off, the water froze. If your kid does that, like puts a glass of water in the freezer and leaves it there, what happens? Two things. First, the water expands, it breaks the glass, the kid gets punished. In this case, the water expanded and it broke to relieve the stress for over 1,000 miles across this equator. It's the biggest, or one of the biggest canyon systems in the solar system, much bigger than the Grand Canyon. Now, in addition, there are all kinds of other interesting things. There are mountains that look like they've sunk down into moats. There's a polar cap that's like a science fiction polar cap. It's not a big, bright white polar cap like the Earth or Mars or anything you've ever seen before. It's like an anti-polar cap. Of course, it's from the underworld. Right? This material, this red stuff, we believe, and we published a paper on this in Nature, is material that has escaped Pluto's atmosphere. And as it's flowing away, run into Charon, and at the poles where it's coldest, it sticks. It cold traps out, and then as the sunlight shines on it, it makes chemical reactions that turn the methane, and it's primarily methane that's escaping, into long-chain hydrocarbons that have just this color and just the same spectrum as this material has. We can reproduce that in laboratories, and we have done that to show that it matches. And there's a lot more that I could tell you about Charon, but it's getting late in the hour, so I want to go on to the star of the show, Pluto. This is an image that was created, actually it's a view as if you were an astronaut standing above Pluto, 1,000 kilometers, about 600 miles, looking down on the surface. Here's a true color picture of the hemisphere we flew by, and in the green box, I'm showing you where on the planet we're looking. This is basically the heart of Pluto. It's the western lobe of that heart. Again, north is always to the top. This enormous white feature is that western lobe of the heart. It is a nitrogen glacier of unprecedented scale. There is no glacier of this size anywhere in the solar system that's ever been seen except on Earth. And of course, on Earth, the glaciers are made of water ice, not nitrogen. And on that glacier, we have not been able to find a single crater. Right next to it, there are very heavily cratered terrains that date as old as Charon's surface to 4 billion years old. This system, this glacier, which, as David said, is flowing. We see evidence of avalanches, of subduction under mountains, of convection, of swirl currents as it maneuvers around obstacles of water ice. This system is the scale of Texas and Oklahoma combined, and apparently it was created yesterday, geologically. Because we can't find a single crater, we can't really get a precise age, but it can't be more than a few million years old. The planet is 4,500 million years old, so this really was born yesterday. There's lots of other complexity, big canyon systems and mountain ranges that ring the glacier that tower 15,000 feet into the sky. They're made of water ice, not rock, mountains made of ice. This is one of my favorite pictures. It's an area to the west of where we were just looking, with mountain ranges about the size of the Rocky Mountains in my home state of Colorado. And these mountains are just about as tall, too. They're 3 to 4 kilometers high, 14,000. They're 14ers. And what's most enchanting about these is that they have snow caps. This little planet in the Kuiper Belt has snow caps. It's just amazing. Except this snow isn't made of water ice. It looks like water ice. It looks very familiar. At the crest of all the mountains is this bright white stuff, but our spectrometers have fingerprinted it. It's methane. It's natural gas, condensed natural gas. Now, we knew that methane was common on Pluto. Where's Dale Cruikshank? There's Dale. Dale discovered methane on Pluto in 1976 with 2 of his colleagues. It's all over the planet. Apparently, it accumulates at high altitude as snow caps on the mountain ranges. What a sci-fi world Pluto turned out to be. Now, here's an image a lot like David showed you. I love this. This one was taken just a few minutes after the other one, maybe 20 minutes after flyby. And you can see how rugged the terrains are on Pluto's surface. This feature, we believe, is a volcanic caldera the size of Mauna Loa that spews ice from time to time, not lava. You can see these concentric haze layers in the atmosphere that stretch up 500,000 feet into the sky above Pluto. And you can see the big nitrogen glacier and a lot more detail. It's really an amazing success story. No one thought we could convince NASA to fund a mission to Pluto. And then when there was funding and there was a competition, no one thought that the New Horizons team would be the winners of that competition. And when we won, people said, you won, but you lost. But we built it, and we launched it successfully, and we flew it all the way across the solar system. And I'm going to end with my favorite picture of the entire flyby. This is a true color picture looking back at Pluto. Pluto's sky is blue, just like the Earth's. There you see it. You remember I talked about the navigation challenges and how one of the scientific objectives is to fly through Pluto's shadow so we could use the ultraviolet spectrometer to determine the composition of the atmosphere. This image was taken while we were in Pluto's shadow. Looking back, the sun is on the other side of the planet. The sunlight is filtering through Pluto's atmosphere. The entire disk of the planet is plunged in darkness because this is the night side. The reason I love this picture more than any other is because the only way you can get this geometry, the only way you can see Pluto this way, silhouetted against the sun, is to be on the far side of Pluto. This is the image that says, we did it. We really did it. Thank you very much. David, come on back up.
It's really beautiful, isn't it? Thank you, Alan. I'm just going to make a few more remarks, and then we'll bring Alan back up, and we'd both be happy to take your questions. I just wanted to comment a little bit on the reaction to the flyby, the press reaction, the public reaction. It was overwhelming. After all of that toiling for so many years that Alan and I have been talking about, a lot of it in obscurity. A lot of the public didn't know that New Horizons was happening. The launch was in the news a little bit, and then over all those years, I think a lot of people forgot that we had a spacecraft on the way to Pluto. And then, of course, at the time of the flyby, it burst back into the public view in a big way. And this encounter was like no other planetary encounter in history. Alan mentioned a little bit about what it was like to be there, the crowds of people, the excitement, the team itself, the emotion after all that effort, and then the flyby is very concentrated in a short period of time, all the really intense activity, and everybody's sort of sleepless and breathless, and it's very surreal, the sense of I talked to a lot of the team members about what the experience was like to be there, and a lot of them had this feeling of, time dilation, time stretching out, and this feeling that this is one of the peak moments of my life. And I always want to remember every detail because I'm going to be playing back this tape in my mind for the rest of my life. And yet I'm so busy. I've been up all night and I've got to analyze this image and go do this interview. And, it was this crazy time. And then for the people gathered there, the excitement was just so intense. There was real drama because Alan showed you that picture of the hug with Alice Bowman at the time when we got the phone home message. But there were many hours where we knew that New Horizons had passed by Pluto, but we didn't know if it had worked because it takes so long for the signal to come back. We knew it had passed through the system. It was already on its way out from Pluto, but then everyone was there gathered waiting for the phone home moment. And that was real drama. It wasn't staged, and it was an auditorium of people like this, watching on the screen what was happening just across campus where Alan and the team were gathered. And you saw Alice Bowman with her screens watching for these green beacons and having her different leads of her engineering teams reporting in that the navigation had worked and that the memory was full and that no emergency procedures had been triggered, and that basically everything had worked, and that the spacecraft was outbound from Pluto with memories full of all the information. And when that was reported, and we saw Alan and Alice hugging, and everybody, just everybody was just like ecstatic in the auditorium this size. But the really incredible thing was that it wasn't limited to that location, because unlike the Voyager encounters, which in a way were the last time something like this had happened in 1989, something had happened since 1989. The internet had been invented. And so this encounter was immediately a global phenomenon. And you had this sense of participation instantaneously around the world. The images were going out, and people were tweeting, and it was on Instagram, and messages were coming in. And there was this global feeling of participation that was so cool. And Alan and I, while we've been doing this tour the last couple weeks, talking about this new book, we've been meeting people with stories of where they were during this. It's reinforced this sense that it really was a global event. The other night we met this guy who was the head of the Astronomical Society of Guyana. And he was telling us how he and his friends out in their village there with their internet connection were, at the time of the flyby, were watching the images coming in, and they were hugging and cheering. And then we met this other guy who, during the flyby, was in a bunker in Kabul, serving in the Marines. And he and his colleagues there, and he said the computer system wasn't that good because it's all hardened and whatever, but that they were hitting refresh, and every time a new Pluto image came in, they were like, woo! So, this was really something that, because now we're globally connected, that people were able to experience simultaneously as this sort of global human celebration of this uniquely human achievement. So it was tremendous, and the press response was so cool. This is the New York Times the very next morning on July 15th, 2015, and the team had talked for a long time about when are we going to transmit the New York Times picture. It was this sort of idea they had that if everything worked, that they would on the 15th get a picture that would be on the cover of the New York Times, and it was. Here it is above the fold. But what's so cool on this slide, this is the New York Times issue from exactly 50 years earlier to the day, July 15th, 1965. And remember I told you about the Mariner 4 flyby of Mars, and remember that date? Well, here, this is 50 years to the date, that first flyby of Mars, returning the first pictures from the surface of another planet by spacecraft. 50 years later, here we are at Pluto with New Horizons. And these two New York Times covers, these two images cap an era where our species was first sending spacecraft to the other worlds of the solar system. And it's really a wonderful thing about our time that we're alive, that we've been able to do this. And it's just the beginning of our exploration of the universe, but it represents what Carl Sagan used to call the preliminary reconnaissance of the solar system. And it began here and it ended here. It's not over, but as far as the classical planets that we knew about when we started exploring, now we've been to all of them with New Horizons. And the global creativity that poured out of people's response to this, as Alan mentioned, NASA had 2 billion web hits, the largest web response ever to an event with NASA. And people started just taking those images and sending them back to us with all kinds of incredible creativity and humor and fun and insight. And this is just one sample of some of what appeared on the web, all these memes, the little prince and the Death Star. But also some really cool scientific, this is showing the transition from the best Hubble Space Telescope view of Pluto before New Horizons to what Pluto actually looked like when New Horizons revealed it, and the way the moons spin around. And people were just doing all kinds of beautiful, crazy, creative stuff. And so it was really gratifying after all of that to see that the world responded in such a sort of joyous and insightful way collectively to exploring Pluto. The last thing I want to mention is that New Horizons is not done. It's still going. It's out exploring the Kuiper Belt, and it's going to intercept one more target. There's going to be another flyby this New Year's Eve, 2018, 2019, New Year's Eve. New Horizons is on track to intercept an object that's now been nicknamed Ultima Thule, which means beyond the farthest frontier. It's a Norse expression. And we don't know very much about it. We know that it's small, maybe about 30 miles across, and it's sort of got a strange shape, a double lobe. We don't know if it's actually two objects orbiting each other or two pieces squished together. Beyond that, we know nothing. And we do know that it's 1 billion miles farther out than Pluto. By far the farthest thing that we will have ever explored. And that is another encounter coming up this New Year's Eve. So pay attention and watch for those pictures. And after that, who knows? New Horizons may be able to encounter more objects. The team is going to look very hard and try to find something else that New Horizons can intercept. But either way, it's going to keep going. And when I say keep going, I mean it's really going to keep going. New Horizons will be the 5th human-built spacecraft that is going fast enough so that it will completely escape our solar system. The other two were Pioneer 10 and 11 and Voyager 1 and 2. New Horizons is now following in their footsteps. It's going fast enough so that the sun's gravity will never stop it. It will keep going. It will escape our solar system, and it will literally wander forever through the galaxy. It will outlive, I would guess, human civilization. It will certainly outlive the Earth and the sun. And it's really eternal. So there's one little part of the story of New Horizons that truly is eternal, a little memento of our civilization, of our time, our curious and inventive species sent this object past Pluto that will keep going, and if anybody ever finds it, they'll know something interesting about our civilization. And with that thought, the eternity of New Horizons, wandering through the galaxy, carrying some ashes of Clyde Tombaugh along with it, I want to stop there and bring Alan back up, and we'll entertain your questions. Thank you.
Is Pluto more than just nitrogen, water, and methane, or is there other stuff underneath that, or?
Yes. That's a really good question. Down below the methane and the nitrogen, the more exotic stuff, is Pluto's crust, which is made of water ice. And it's actually several hundred miles thick, and at the bottom of it, where the temperatures are warm enough, the water ice actually melts, and we believe there's a liquid water ocean down there. Pretty amazing. And below the ocean is the core of the planet, which is made of rock. And actually, Pluto is about 2/3 rock by mass. It's one of the surprising things we learned back in the 80s, is kind of a who ordered that moment. When we could first know the size and the mass, we could get the density and show that it's really a rocky planet with an icy exterior. And that was very surprising to learn in the beginning, that on the edge of the outer solar system was a rocky planet. And so that's a great question. Pluto's mostly rock, 2/3, about 1/3 water ice, and all the stuff that's exotic is just a veneer on the very surface. And then we'll take a question from over here.
Along those same lines, what's the atmosphere made of? I know that shot is, as New Horizons was pulling away, shows that beautiful blue. So is it oxygen?
It's actually largely nitrogen, which is cool because that's the air in this room that you're breathing is largely nitrogen. And there's also methane in the atmosphere. And what's interesting about that is that the substances on the surface, that big glacier, is nitrogen. And Alan pointed out the methane snow caps on top of the mountains. So you have one of the interesting things about Pluto is that the stuff that's forming the air is also a lot of the same stuff that's on the surface in solid form. And they're exchanging all the time. So you have weird seasonal effects and this sort of morphing between the atmosphere and the surface that's a result of the fact that the same materials are formed. It's as if on Earth, the rock, then the atmosphere was gaseous rock, and it's not. But on a place like Pluto, it's the same stuff in the air and plating out on the surface.
Thank you. Yes, sir.
Yeah, so I had a question about that nitrogen glacier that has that new surface. So I understand Pluto's on its way out from perihelion. Is it possible that it actually gets warm enough to resurface itself every orbit?
It could be. We actually see patterns on the surface of the glacier, which we didn't show pictures of, that the geologists will call a cellular pattern, not meaning something's alive there, but geological cells that are best modeled by a process like convection, like a roving boil on a pan that you heat. It's causing a vertical overturning. So no doubt, well, I shouldn't say no doubt, but probably this feature is very old, but it's constantly renewing itself and therefore erasing craters. Mm-hmm. And the effective age of the surface, what we call the CRE, or crater retention age, is what's very young. The actual material may be very old, but something is causing a heat source below that nitrogen glacier on that vast scale the size of Texas and Oklahoma combined. And we're not sure what that is. Scientists have ideas. We're not sure which one is right, or if any of them are right, and there's another idea we haven't found yet. We'll eventually learn that, either through making a solid case from computer modeling, or when we send the orbiter back and we get more data in the future, which is what we want to do. And we can really constrain what that energy source is.
Thank you.
Yeah, over here now.
It was such a nice flyby event that many movie stars and singers and celebrities came to
Yes.
you, right? Would it be a good opportunity to use this marketing tool, marketing vehicle, to collect funding for the next mission? And you can launch more probes, maybe larger probes, and etc.
Do you mean like if they could have charged money to attend the flyby or had pay-per-view elsewhere?
Well, I'm not sure about technique, but if there is some interest from the society, even movie stars come, there is an opportunity here.
Yeah, absolutely. It's not like you're going to raise money through the flyby, but you're absolutely right. I mean, everything we do, missions funded by NASA, it's all based on public support. It depends on, it's supported by the taxpayers. And so public interest in what we do is crucial. And that is one of the benefits of something like this flyby, and the tremendous excitement generated by the imagery and the media response is that, at least for a brief time, it's incredibly visible what we're doing, and that's the payoff for that investment. that people make. And yes, the excitement that's generated, we hope and we believe does help contribute to support in the general public to continue and doing more exploration, as well as inspiring young people to be interested in science and exploration, and also inspiring people to realize that our country and our society can do wonderful things. That we're still on our game in some very important ways because, we did this. So it's something to be proud of.
Yes, sir.
So thank you both for a compelling presentation about a compelling topic. Alan, as you know, I'm a science educator, and a lot of times we're battling misconceptions. And I want to also thank you for being an eloquent defender of Pluto's status as a legacy planet. But I kind of wanted to ask you if you'd be willing to go to the other side and change a misconception. Every time you say Kuiper Belt, a belt is flat, and this is an area that is massively large and shaped like a giant torus or a donut. When I educate fifth graders, I call it the Kuiper donut. So I don't know if that's a good term, but do you have any ideas, or would you be compelled to help people along in that regard?
I've never been asked that question. I like donuts a lot, so I like this idea.
Yeah. Maybe if
quite
you
a
could
bit.
take a tip from Elon Musk, you'd call it the BFD.
Okay. Let me also say, though, about the Pluto planet thing, that, of course, the whole thing with the astronomers is just a bunch of BS. And we all know what that stands for, bad science. And we can talk about that, too, if somebody has a question about it. But as far as actually, there was a time, let's see, what did we call it? I don't know, but that donut idea is a really good one.
Okay, glad I
Let's talk
planted a
about
bug
that.
in your ear.
Thank you.
Thanks.
Kuiper donut, okay.
So my question is there a particular aspect to the New Horizon probe's design that you think makes it unlike any of other spacecraft of its type?
There are a number of really innovative aspects to the design. And in the book, we talk about how we actually managed to get it in the cost box by doing some pretty radical things, taking some risks, but also we made some intelligent compromises, like a much lower bit rate communication system than Voyager. In a way, we went backwards. But it allowed us to save a lot of money, not because the communication system was less expensive, it was, but it allowed us to only need one instead of two nuclear power generators. And those babies are $80 million apiece. But what was really innovative was that we are the first mission to extensively use hibernation for operational purposes, so that we didn't have to babysit the spacecraft and pay flight controllers to sit at control panels 3 shifts a day, 7 days a week for 10 years. And that actually is a huge savings when you integrate over all the salaries in 10 years. And people thought at first that if we didn't babysit the spacecraft, things could go haywire, and by the time we got word of it, it would be too late. The spacecraft would have died for some reason, like a fuel leak or repeated power problems or computer resets. But we put a lot of thought into the software for how it could take care of itself. And now that hibernation technique is used pretty extensively for other missions. And it's kind of become ho-hum. But we're very proud of having really taken that out of the sci-fi future realm of what spacecraft could do and implementing it. So thanks.
Thank you for coming.
Who's next?
Thank you for the really engaging talk. I remember when the flyby happened 3 years ago, I was curious like how close the spacecraft actually came by Pluto. And I remember actually being surprised that it was like something like 12,000 kilometers
That's right.
flyby when the planet was only 2,000 kilometers wide. And at that distance, Pluto is probably no bigger than like your fist held at arm's length. So in my mind, I was thinking like the camera technology on the spacecraft must have been pretty extraordinary to be able to capture all that detail, given that, if I was just using my own cameras at home, like DSLR cameras, that it wouldn't come out anywhere with that level of detail. So as somebody who takes a lot of photos, and I'm also an astrophotographer, I take photos of galaxies and nebula. I'm kind of curious if you could share a little bit about the camera technology, maybe share like, the sensor size, the resolution, the focal length. Like, was it like a massive telephoto lens that you used, or
Yeah.
what kind of cameras did you have on
Well,
there?
first let me say that your numbers are right, that basically we flew by something the size of the United States from the distance of Japan. Okay, and we didn't want to come closer because that would actually compromise the science. Remember, we're going 32,000 miles an hour, and if you don't want the images to be smeared, so you don't want to get too close because then you can't compensate for the smear. And also remember that the light levels at Pluto are 1,000 times lower than in broad daylight. So the camera has to be very sensitive in these very low light levels. And all those things conspire together to make the technical challenge that you described. Both of our cameras, the Ralph color camera, which also has a black and white component, what we call a panchromatic, and the Lori telephoto, which is really a telescope, not a lens, use CCD detectors to form digital images just like your phone does, but much more sophisticated CCDs than that. And the spacecraft actually tracks the targets to compensate for motion as it's going by. So as it's going by the planet, it's actually turning at just the right rate to freeze the motion. And that allowed us to get images as good as 70 meters per pixel. That wasn't achieved on Mars till the 6th mission to Mars. But we had the advantage of much later, 2000s era technology. And the mapping that we did was good enough that had we flown over, let's say, San Francisco at the same altitude with New Horizons and looked down, we would not only be seeing the layout of the city, but we'd be seeing the individual buildings downtown at that resolution. And for the larger ones, we could tell their shape. And that's pretty impressive that we could do that and map the planet that way on a fast flyby on the first try, I think.
Thank you.
3 more questions. Okay, thank you very much. We'll go to this side.
What was both of your favorite parts of the amazing journey to Pluto, and why?
Favorite parts of the amazing journey? Wow. Well, I mean, you have to say ultimately the flyby itself and that moment of first seeing the detailed pictures and realizing that everything we thought we knew about small planets that far from the sun was wrong, because you see this image basically, it wasn't quite that good when we first saw it, but basically that geography, you see that bright heart, it's clear that there's something going on there, an area that's fresh and new and has no craters, so there's some activity. It's vibrant, it's varied, it's beautiful. Just the appreciation of how beautiful it was, and at the same time how interesting it was and how much new understanding we were going to get from it. You knew immediately when you saw those first images that this was something really, really special. So that moment, but then I would also have to say the launch was extraordinary because it was, very physically powerful to behold, and there was a lot of anxiety leading up to it. Was it going to work? It's a moment of real risk if something could go wrong, and yet afterwards, the joy and the celebration and seeing this team that had worked so hard, partying and having a great time and just celebrating for a moment before they got busy with the hard work of flying across the solar system. For me, those are 2 very special moments that stand out.
I was going to bring up the parties myself. But actually, David answered very eloquently about the science, the big discoveries, how complex Pluto is and how active it is and how that defied our imagination. The biggest surprise of the whole journey for me was something completely unexpected, and it was not just the scale of the public response, but the number of people that have written our team, one way or the other, about how it personally moved them or affected their lives. It caused Well, we write about this at the end of the book in the coda, how people just come out of the woodwork and they'll say, you know, my son was a failing student, a slacker, who watched your flyby and in 9 months has become a straight A student. And it said, I want to do that when I grow up. And that woman that I'm talking about actually said it to me in tears while shaking my hand. She said, your project saved my son's life. That kind of response, as a scientist, you know, to see that it really moved and changed people's lives that way, was probably the best discovery of New Horizons. Really, for me, that was it. So thank you for asking.
Thank you.
So we have 2 more questions? 1 more question? Which one? 2. Okay, we can take 1 on this side and 1 on that side.
Given the bandwidth, transmit power, antenna gain, path losses, things like that, how much longer will you be able to maintain a two-way link? And can you upload more sophisticated data compression and error correction codes that weren't available when it was launched to extend that?
He's violating the 1-question rule. They're both really good ones.
That was a two-part
It was a
question.
2-part.
Yeah.
Okay, it's 1 question with 2 parts. So we actually can calculate that with this transmitter and current day technology on the ground, we can communicate with New Horizons about 7 times farther from the sun than it is now.
Wow.
Set to about 200 times as far away as the Earth is from the sun. However, that's not going to happen because every year the radioactive decay of the plutonium produces less power. And somewhere in the late 2030s, we won't have enough power to run the spacecraft systems, and we'll have to turn it off. And we're only going to be about 70 times as far away, not 200. So we have the capability to communicate further away, but we won't make it that far because the nuclear battery won't do it. And therefore, the second part of your question about more sophisticated encoding or a better ground system or whatever probably won't matter because we're just going to run out of power in the battery. Thank you, though. Last question.
When do you plan to send your next mission past Pluto, and are you going to send astronauts in the future?
Well, what we'd like to do next is send a robot orbiter to do the next logical phase of exploration, to go there to stay, watch time variations, bring kind of instrumentation that we couldn't bring on New Horizons, like mass spectrometers to sample the atmosphere, radars to probe through the ice to find out how deep it is, and if there are liquids below it, magnetic sensors called magnetometers to look for evidence of currents in that ocean that might be deep down under the ice and things like that. Astronauts will come with time. I'm sure I won't live to see it, but you'll probably be the commander of that crew.
Yeah, I mean, to answer your second question, will we send astronauts? Absolutely yes. Not on the next mission to Pluto, but people will go there because people are going to go everywhere in the solar system eventually because that's the kind of species we are, right? We once lived only on the continent of Africa, and but then we ventured farther, and we human beings explore, and we go to new places. We can't help it. We're like cats. We're really curious, you know? And that's just our nature. And so extend that farther in the future, and there's no doubt that people will eventually go to Pluto. And maybe you will be part of that mission.